Standard deviation. When we measure a bunch of data, there's two things we often want to know in order to make predictions or statements or understand the data. We want to know what is normal. For that we've got the mean, the median and the mode. And we want to know how spread out the data is. And for that we've had the range and interquartile range so far, but we also have the standard deviation. This is a measure of spread. And what it describes is, on average, how far away from the mean is the data. So let's just write that, and we'll go through it. So, two really quick examples. If I had two classes, very small classes of 5 students, and they both did a maths test, and these were the scores. These data sets both have a mean of 10, but this data set is not spread out at all. Everybody got 10. Their standard deviation, that's the symbol by the way, that is the Greek letter sigma. The standard deviation here is 0. The data is just not spread out. If 10 is the mean, then the distance from the mean for each of these, this is 10 away, this is 5, this is 0, this is 5, this is 10. If I averaged the distances from the mean, 15, that's 30 divided by 5, the standard deviation here is 6. I'll just get rid of that there. That is, on average, each data point is 6 points away from the mean of 10. So this is standard deviation. The calculation is a bit more complicated to deal with the maths, but that is roughly how it's done. No need to write these down, but you can see from data, even if the standard deviation isn't given, a data set that's more spread out has a higher standard deviation than a data set that's quite clustered. So this team here has a higher mean, but they're more variable in their scores. This team is more consistent, but does have a lower mean. So, we need to be able to find the standard deviation of a set of numbers. We can do this with a graphics calculator, with a table, with a formula in Excel, by typing all the numbers in and saying standard deviation please. The table takes a while. It can be interesting though to help you see how it's worked out, but I'll hope the formula does that instead. So the standard deviation formula, and we'll talk about why it's like this. We have to find the distance of each score from the means. We do have to find the mean first. The problem is, if I just find the distance from the mean, I've got to be able to calculate that. I can't just do it like this where I went, oh, that's 10, that's 5, that's 0. I've got to be doing the same thing for each of these. And if I do the score minus the mean, I'd actually do 0 minus 10, I'd get negative 10. I don't want to have negatives and positives. I want the absolute value of just the distance, which is what I found here. To get that in a formula, what they've chosen to do is they've squared each distance, because squaring a negative gets you a positive, and then they square root at the end to reverse that. So what we're going to do is we're going to take x1, the first score, and subtract the mean, and then we square it. We add on the second score minus the mean squared. So this is effectively what I did up here, was I found the distance from the mean for each one. But the formula squares so that we can get rid of the negatives. Plus, now I don't want to write a formula that says first score, the second score, the third score, fourth score. So we just put 3 dots and then plus, and the last x would be the nth score. And that says every score, subtract the mean, and square it, and add them up. And once we've added those up, we want the average, so we're dividing by n, and we square root at the end to reverse the fact that we squared it. Sorry about the bell there. So we find the mean, that's 1028 divided by 5, which is 5.6. Every score minus the mean. We don't have to show that in our working, we can just get the score. So 2 minus 5.6, negative 3.6, and we square it. 4 minus 5.6, negative 1.6, and we square it. 5 minus 5.6, negative 0.6, square it. 8 minus 5.6, 2.4 squared. 9 minus 5.6, 3.4 squared. Divide by n, then square root. That is sufficient working. After that, you can simply type it into the calculator. Simply, she says, because that's going to be the square root of, in brackets, and another bracket there, 3.6, negative 3.6 squared. It doesn't actually matter, you'll get the same answer, but let's be doing the right thing. Negative 1.6, close bracket, square it, plus negative 0.6, close bracket, square it, plus 2.4 squared plus 3.4 close bracket, close bracket, square it, close the whole bracket, divide by 5, which I should have written here instead of n, pop out from the square root, equals 2.58. Your standard deviation equals 2.58, which says on average these are 2.58 points away from the mean of 5.6.